two-way ANOVA followed by post hoc test in Excel, SPSS, Jamovi and GraphPad Prism. Factorial ANOVA, or in this case two-way ANOVA in Excel. Here in this Excel data sheet I had inserted data that have two factors, two levels, or two independent variables and one dependent variables. The first factor is the job factor, in which there are four groups: doctor, dentist, pharmacist and nurses. The second factor, or the second level, is the gender, male or females, and the salary earned annually in pound for each individual is inserted. So we have here two independent variables, jobs and gender, and one dependent variable, which is the salary. And to do two-way ANOVA, since we have here two factors, two-way ANOVA statistical analysis, three hypotheses are generated. The first hypothesis states that there is no differences between means of factor 1. So this hypothesis will examine whether there is a difference between all the four occupations: doctor, dentist, pharmacy, nurses, in terms of their salary earned annually. The second hypothesis, the null hypothesis, will address whether there is a difference between gender, male or female, in terms of the salary earned annual, as the null hypothesis states that there is no differences between the means of factor 2. And the third null hypothesis states that there is no interaction between factor 1 and factor 2. So this hypothesis will examine whether the factor 1 and factor 2, whether the occupation and the gender can influence the salary earned by individual. To test these hypotheses, two-way ANOVA statistical test will be used. So to do that, click on data, then data analyze, select factor ANOVA two-factor with replication, click on OK, and in the new window select the input range, and the input range select the data with the title of the column, and for the rows per sample, which represent the second factor, in this case is the gender. So we have 12 male and 12 female. So per sample we have 12 participants that are male, and in the second sample we have 12 participants that are females. Keep the alpha at 0.05. If you click on OK, a few tables are generated, one for the male, a second for the female, that both shows the average for the salary earned by doctor, dentist, pharmacist and nurses. The most important table or part is the ANOVA table, which will answer the three hypotheses. The first cell here, sample, will represent the gender factor, male or female. There is significant differences between the salary earned by male and females. Just going to edit this a little bit by clicking on format cells and reduce that, make it number, reduce it to 4 decimal. As we can see here, a p-value is generated. So this p-value indicates that there is a difference in terms of the salary earned between males and females. The second cell is the column, which shows a significant difference and this column represents differences between 4 groups for factor of the job. So that also states that there is a difference between the salary earned by doctors compared to dentists, to pharmacists, and to nurses. The third cell here is the interaction, which examines whether there is an effect of both the jobs and the gender on the salary earned by individual. Again, it shows that there is a significance, so thus the job and the gender, whether male or female, can affect the salary earned by individual. So this is the way to do two-way ANOVA in Excel for a data that have 2 factors or 2 levels. Two-way ANOVA followed by post hoc test in SPSS. Two-way ANOVA is factorial ANOVA. Here in this SPSS we have data that have 3 variables. The first 2 variables which are independent variable, the job and the gender. So here we have the first factor, which is the job, the second factor, which is the gender, and the third variable is the salary variable, which is continuous, and this salary is the dependent variable, and it's measured in pounds, and it is the salary earned annually by individuals or each individual. For the factor job, there are 4 different levels or groups or categories: doctor, dentist, pharmacist, nurses. For the gender, there are 2 categories: male and females. So we have here 2 factors with sub-levels. This is an example of 4x2 analysis, as we have 4 levels and for the job and 2 levels for the gender. To find out whether there is a differences in the salary earned by each group in the factor 1, doctor, pharmacist, dentist, and nurses, and whether the sex or the gender of an individual also have an effect on the salary, whether a male have more salary than a female. And since we have here 2 factors, the way to do statistical analysis is to perform two-way ANOVA statistical test, as we have here 2 factors. To do the test, 3 null hypotheses will be generated. The first null hypothesis states that there is no differences in means between groups for factor 1. The second hypothesis states that there is no differences in the mean for factor 2, males and females. And the third null hypothesis, there is no interaction between factor 1 and factor 2. To perform two-way ANOVA, click on Analyze, scroll down to General Linear Model and select Univariate. In this new window, drag the job into the fixed factor, the gender into the fixed factor, as we have here the 2 factors, and the salary, which is the dependent variable, into the dependent variable area. Click on Plot or Plots, and for the profile plots, select Job, drag it into the horizontal axis, add it to the plot here, select the gender, drag it into the horizontal axis, click on Add, and then select again the job into the horizontal axis, the gender into the separate lines, and click on Add. Click on continue. Click on post hoc test. For post hoc test, since gender is just 2 categories, we're going to select the jobs as it have 4 levels in it. And we're going to stick with Taki here. Click on continue. And for the EM estimated marginal means, click and select all and drag it into the display means for the overall jobs, gender, and the interaction. And for compare main effect, select the LSD. Click on continue. Click on save, and then tick the unstandardized. Click on continue, and for options, click on descriptive statistics homogeneity test for ANOVA assumptions and estimates of effect size. Click on continue, and if you click on OK, several tables are generated with plots towards the end. So in the first table, which shows the descriptive data for the job, which have 4 levels: doctor, dentist, pharmacist, and nurses, and there are 24 individuals in each group. And for the gender, when the data split by gender, have male or female, both are 48. The second table is a descriptive statistics that shows the means and the standard deviation for each factor in combination with the second factor. For doctors whom are males, that's the mean for the salary or the average they earn. And for doctors whom are females, this is the salary, the average salary they earn. So this is the description of the data for both factors. The third table is the test for homogeneity of variance using Levin's test. It shows that there is no homogeneity of variance. The data has violated one of the assumptions for two-way ANOVA, which is homogeneity of variance. As here shown from the table, there is heterogeneity in the variance. However, the ANOVA is a robust test, and we will keep this in mind, but we will continue with the analysis. The next table is the table for test of between subject effect. This table will determine whether the null hypothesis can be accepted or rejected based on the significant level p-value. If the p-value is less than 0.05, then we reject the null hypothesis. The two factors, the factor for the job, the factor for the gender, and then the interaction between the two factors. So for the first factor, the effect of job on the salary, or whether the salary is affected by whether you are a doctor or a dentist or a pharmacist or a nurse, it shows that there is a significant differences. So jobs category have an influence on the salary, and as we seen here, that doctors having higher salaries compared to dentists and pharmacists and nurses. So there is a significant differences in terms of salary based on the profession. So this factor, in this factor, there is a difference in the salary. For the gender, whether you are a male or a female, whether your salary is affected by your gender, the p-value is less than 0.05. So there is a significant difference between male and females. And for the interaction, whether jobs and genders can have an influence on the salary, again, there is a significant difference. So all the null hypotheses will be rejected, and the analysis here showed that there is a significant difference between levels within job category or job factor, and differences between gender for the gender factor, and also interaction between the two factors. The next or the following tables look at the grand mean, the estimate. What is important also to consider in this analysis is the pairwise comparison, since we found out that there are differences between all four professions in terms of salaries. Then the Taki test will compare groups together and to make all possible combination to find which one is significant and which one is not. Here in this pairwise comparison, doctors compared to dentists, there is a significant differences in the salary. When the doctor also compared to pharmacists or to the nurses, again there is a significant differences. So this pairwise comparison will pinpoint the groups or two groups that have differences in the salary. The first test here will show that there are differences between all the four groups in the factor job, and the pairwise will determine pairs by pairs significance of differences. If we scroll down to the again here shows that interaction between job and gender, doctors with whether male or female and their mean. Again, it's repetition of what is in the tables above. The most important one I would like to look at is the plot here. As shown here, when plotting the factor 1, which is the job with the salary earned, you see that the doctor have the highest mean for salary and the nurse are the lowest. For male and females, we can see that the average salary is higher for male compared to females, and in the last one showing that gender and occupation have an effect on salary earned by individual. This is the way to do factorial ANOVA or two-way ANOVA in SPSS. Two-way ANOVA followed by post hoc test in Jamovi. Two-way ANOVA is factorial ANOVA. The ANOVA is used when there are more than one factor or more than one independent variables. When there are multiple independent variables, then if there are two independent variables, then the two-way ANOVA statistical test is the one to use. Here I had placed data in Jamovi. There are two factors in this data, two independent variables. The first one is the job variable or the job factor. It has four levels or four groups or categories: doctor, dentist, pharmacist, and nurses. The second factor or the second independent variable is the gender, which have two levels or two categories: male or females. The salary is the third variable, which is the dependent variable. It is a continuous variable, and it is the salary earned by individual annually in pounds. To find out whether there is a difference in the salary earned between the levels for factor 1, between doctors, dentists, pharmacists, and nurses, and to determine whether there is a difference in the salary earned by male or female, i.e. the second factor, which is gender, and to find also whether the salary is influenced or affected by the combination of both factor, jobs and gender. Then two-way ANOVA or factorial ANOVA statistical test will be performed. 3 null hypotheses will be generated. The first null hypothesis states that there is no differences in the mean between level for factor 1. The second null hypothesis states that there is no differences in the mean between the two groups for factor 2, which is the gender. And the third null hypothesis states that there is no interaction between factor 1 and factor 2, i.e. there is no effect of job and gender on salary. The way to do two-way ANOVA in Jamovi: first we will explore the data and look at the mean and the standard deviation for each factor. And to do that, click on exploration, click on descriptive, and then in the descriptive move the salary to the variables, and the split by, we're going to split the data by the job and by the gender. And simultaneously the Jamovi will produce a table, and we're going to make it more variables across rows as shown here. The table has been generated and it shows factor 1 with the 4 levels in it, factor 2 with the 2 levels in it, and the number of individuals in each group or subgroup, the mean for each categories, and the standard deviation and the median. We could also plot a box plot as drawn here, shows the box plot for the two factors, the male and the female. The gender here is put here on the x-axis is the gender, male and female, and the jobs are color coded. We could also produce a histogram to show the distribution of the data. We could also go back again to statistics and insert into the table confidence interval for the mean, as shown here, confidence interval for the mean, and that's give a confidence 95% confidence intervals for upper range and lower range. So the essence of using Jamovi, it is easy and straightforward to use, and the table is generated and it can be copied and inserted into Word documents or into a PowerPoint presentation. Now we have generated this table, we have generated a few plots. Then we need to do the statistical test, which is two-way ANOVA. Click here on this icon, ANOVA, then click on ANOVA here. Another window will appear. Again, we are going to move the salary into the dependent variable, because that is the variable that we are measuring. And then we move the job into the fixed factor, factor number 1, and then the gender into the fixed factor, factor number 2. Again, as we can see, simultaneously Jamovi produce a ANOVA table showing that well, in fact, it is answering the hypothesis generated. The first one is the first factor is the job, the second is gender, and the third one is job and gender. From the ANOVA table here, it shows that when we compare the means for the salary earned by the 4 levels in the job, doctor, dentist, pharmacists, and nurses, shows here that there is a significant difference. So there is no similarity in salary. And the ANOVA also produce the F ratio value. For the gender, again, male or females, whether there is a difference in the salary earned based on gender, then the ANOVA table shows that there is a significant difference between earning for males and females. And the third one is the interaction, which answers the third hypothesis. Is there an interaction between job and gender? That does job and gender both can affect the salary earned by individual? Again, the table shows that there is a significant difference and there is an interaction between the two factors. If we click into the model here, I'm going to undo this and do them again just to show you how to do it. First of all, I'm going to move the job into the model terms, into that, and then I'm going to move the gender into the model terms, and I'm going to select both and then click here on the interaction so we can get an interaction as shown here. For the assumptions, again, there are certain criteria that need to be fulfilled before committing and continuing to carry out two-way ANOVA, which is the first one is the homogeneity test, homogeneity of variance based on the Levin's test. Again, the table is generated promptly, and it shows that there is no homogeneity of variances, i.e. there is heterogeneous of variances between the groups within the factor or factors. Then this, although this is an assumption that is required to be met, but ANOVA is robust, and we will keep this in mind, but we will continue with the analysis. We could go for normality test and QQ plot. For contrast, I'm not going to select anything. For post hoc is post hoc test is the test that will determine the combination of groups, two groups that shows significant differences. So when ANOVA table is generated here, it does only shows that there is a difference between all the four groups, but it doesn't show which combination of two groups that have significant difference. And post hoc test will be able to determine that. So we're going to select job and move it to the right side. Again, because it has 4 levels, but gender have 2 levels, male or females. I'm going to move it to the box, and then the interaction between gender and jobs, also move that into the box to generate a table. Post hoc is generated for the job. As we can see here, job is arranged into 4 levels: doctor, dentist, pharmacist, and nurses. So the post hoc will compare first doctor with dentist, doctor with pharmacist, and doctor with nurses, and then dentist with pharmacist, and dentist with nurses, and pharmacist with nurses, all possible paired combination. And it will determine the p-value, whether there is a significance between these two combinations, each individual combination. And the table here shows that there is a significant difference. For gender, again, it is two categories, and we already know that there is a significant difference from the ANOVA table. So again, this is repeated here. For the third one, which is the interaction between gender and job, we can see here that if we arrange the data in pairwise, looking at male and females, doctors, and then this is for the first factor, or the gender factor, and the second one is for the job factor, which is doctor, dentist, pharmacist, and nurses. And let's read the same thing for females. Again, the Jamovi will produce all possible pairwise combination to determine whether there is a significant differences between groups. As we can see here, male doctor compared to male dentist, there is a significant differences in the salary. Male doctors to male pharmacists, there is a significant differences. If we scroll down here and look at male doctors compared to dentists, significant differences. Female doctor compared to female dentist, again there is significant differences. So this table shows all the possible combination pairwise between groups. We could also click on the estimated marginal mean, and I'm going to move the job into the first one here, and then marginal mean, and then move the gender into the second one here. If I click here, I haven't clicked here, so I need to move that to here. And then for a third one is the interaction. If I select the job and the gender and move that into here, we will get a plot. We could also stick to this for the current stage, and if we scroll down, we will see that 3 plots are generated. The first one shows the job factor, which have 4 groups in it, and the average salary earned. The doctors have the highest and the nurse have the lowest. The second plot shows the gender compared to salary, male and females, and we can see here the males earns in average more than females. The last plot is the interaction between those 2 factors, job and genders, and as we can see here that there is a higher mean value for males compared to females, for doctors, and for nurses the same thing, higher for males than females. So this data shows that there is a significant differences between professions, whether you are a dentist or a pharmacist or a nurses, and also whether you are a male or a female. This is the way to do factorial ANOVA, two-way ANOVA in Jamovi. Two-way ANOVA followed by post hoc test in GraphPad Prism. Two-way ANOVA is factorial ANOVA. The test is used when there are more than 1 factors in the data. Here in the Prism, I had placed data that have 2 factors. The first factor is the job or profession. There are 4 levels in the job factor. Doctor, there are 12 individuals there. Dentist, pharmacist, and nurses. Each group or each level have 12 participants. This is for the first factor, which is the job factor. The other factor is the gender factor, which have 2 levels, male or females. The third variable is the salary. So we have here 2 independent variables, which are the factor for the job and the factor for the gender, and a dependent variable, which is the salary or the wages earned by individual per year in pounds. To find out whether there is a difference in the salary earned among the 4 groups for the job between doctor, dentist, pharmacists, and nurses, and whether the sex, whether being a male or a female, will affect the salary earned, and to test whether both gender and profession can have an effect on the earned salary. Two-way ANOVA statistical test will be run, since we have here two factors and one dependent variable. There are three null hypotheses generated to perform this test. The first hypothesis states that there is no differences in the mean for the factor 1, which is the job factor. That means there is no differences in the salary earned by doctors or dentists or pharmacists or nurses. The second null hypothesis states that there is no differences in the mean for factor 2, which is the gender. So there is no difference in the salary earned by male or female. The third null hypothesis is states that there is no interaction between factor 1 and factor 2. To perform the analysis, click on Analyze, and the software will pick the two-way ANOVA will be selected, as we have here two factors, and on the Analyze with Data Set, select all the four groups for factor 1, which is the job factor. Click on OK. Another window will appear, and we are not interested in the repeated measure design, as our data here is not repeated measure. Each participant is different from another, and so we will ignore the repeated measure analysis, and we will select the factor analysis here, since we have two factors, and we're going to rename those factors, since we have in the column the job factor and in the rows the gender factor. Click on multiple comparison, since we have here two factors and the job factor have 4 levels, and the multiple comparison will try to look for differences between combination of paired groups. So in this case, select the compare column means, as we want to compare the mean for the job factor, as we have 4 categories. However, for the gender factor, there are only 2 levels. For the option, click on the option, and then to perform multiple comparison test, we're going to select the Tucky, which is the recommended one. And if I could also choose to click on additional results to have narrative results. For residual, I'm not going to select any choices here. If you click on OK, an output will be generated as shown here, two-way ANOVA results, and the type of the ANOVA is ordinary, and the alpha is set at 0.05. And again, it shows here source of variation, interaction, gender factor, and job factor, and it generated a p-value, and it's give a summary for the p-value and whether it is significant or not significant. For the job factor, it shows that there is a significant, as the p-value is less than 0.05. This indicates that there is a variation in the salary earned among the four professions: doctor, dentist, pharmacist, and nurses. Likewise, gender factors shows that there is a significant difference in the salary earned between male and females. And for the interaction, whether the two-factor job and gender can influence the salary earned, it showed here that there is a significant differences. If we click on the multiple comparison, since we have found out that there is a variation among the job factor, which have four groups in it, then multiple comparison based on Tukey test will be performed, and this test will compare pairwise groups to find out which one of these groups have a difference in the salary and which is not. And the Tukey test will generate a p-value for each combination of tests. And as we can see here, comparing doctor to dentist, doctor to pharmacist, and doctor to nurses all showed significant differences. Dentist to pharmacist and dentist to nurses again shows significant differences, and the pharmacist to nurses showed significant differences. Click on the narrative results, which will give you a narrated explanation of the analysis for looking at the job factor, looking at the job factor with gender, job factor alone, and gender factor alone. So this is the way to carry out two-way ANOVA in GraphPad Prism.